So I was asked to take a look at this problem. This is problem 6.30 from the homework. And in this truss, we are asked to find the force in member CD, HI, and CJ. Now looking at this, I see I've got a pin connection here, which would have a resistive force in the Y direction, another in the X. Got a pin here, again, a Y and an X, so I've got four unknowns with those, and I've only got three equations of equilibrium, so I can't really solve this by going to those reaction forces. However, we talked about using the method of sections or the method of joints when looking at these trusses. And I think since the members I need are HI, CD, and CJ, that method of sections would work pretty well. Now on inspection, I do note that CI here is a zero force member. And I know that because if I were to do method of joints here at I, and I were to sum forces in the Y direction, set that equal to 0, CI would be the only force in that direction. So I know that CI has a value of 0. It's a zero force member. And so what I think I'll do is I'll cut this right down here, and that will give me HI and CD, two of the forces I need. It will also allow me to calculate CH, which then I could use when I'm calculating, say, method of joints here at C to get CJ, or I could cut it again right here to get the force in CJ. I've got both options, so I'll look at both of those. Now I've gone ahead and created a free body diagram of the truss with this first cut, this teal cut. So let's take a look at that. So looking at this, I see I've got 3-foot sections between the forces, which were labeled as 10, 15 pounds. The height of the truss is 4 feet, which gives me a 3, 4, 5 angle on each of these angled members. And now I just need to find, using my equations of equilibrium, these three forces. I've drawn them each in tension, which is often recommended, and we'll just use that. If I get a negative answer, it just means that it is actually in compression instead of tension. Recall that my equations of equilibrium are summing forces in the x direction equals 0, summing forces in the y direction equals 0, and summing moments about some point need to equal 0. In order for this to be static, that must be true. Now looking at these, I've got three forces with x components, three unknowns with x components. I've got one unknown with a y component. And I could also take moments about a couple of points here. I could take moments about C, because both of these forces go through it and have 0 moment arm. That would allow me to solve for this, which is HI. This would be HC, and this would be CD. So taking moments about C would eliminate those two forces from consideration, giving me HI directly. I could also take moments about H, because HC and HI both go through there. That would give me one unknown in CD. Either way, I should be good. So let's go ahead and take moments about C, since that's the first thing I see when I look at it. And since that equals 0, now I'm taking moments about this point. So I've got HI at 4 feet. Its perpendicular distance to C is 4. So I've got 4 HI, and that's positive. And then I've got these three forces giving me negative moments, so minus 10, 15 at 3 feet, and 6 feet, and 9 feet. So I've got those three forces. I've got this one acting at a distance of 3 feet, this one acting at a distance of 6 feet, and this one acting at a distance of 9 feet. And so this will allow me to calculate HI directly. So we've got 0 is 4HI minus 1015 times the sum of those three. We've got 9 and 9, which is 18. So HI must equal 8 times 1015 divided by 4. Let's see what that gives me. It's 2030. So now we know the value of HI. So we could sum forces in the y direction. That equals 0. We've got negative 3 times the 1015. That takes care of those three forces. And we've got minus 4/5 of HC. So bringing this HC over to the other side, I've got 4/5 of HC equals negative, what do we have, 30/45. Multiply both sides by 5/4 to solve for HC, and HC equals negative, switching back and forth between calculators is kind of a pain when they use different methods. So 30/45 is 3806 and 25. Okay, so this is a compression member, whereas this one is indeed in tension. And we expected tension across the top of the truss and compression along the bottom. We know that this angled member is in compression. Now I can sum forces in the x direction, and I've got negative HI, which is 2030, minus HC, which is a negative 3806.25, and I really only need 3/5 of that to be in the x direction, and I've got minus CD. So I can add these together, that 3806.25 times 3/5, and that's a positive, and then we subtract from that 2030, and so it looks like CD will be 253.75. So that would be in tension, actually. We expected compression, but it's in tension, and that would be because these are spread out. And so that works okay. All right. Let me double check my math here and make sure I got that right. We've got a negative 2030. We've got 3806.25 times 3/5. And I need to add those two together, and I get 253.75, bringing the CD over, so we should be good. All right, so now I know CD, I know HI. I need to get H, what do we have? CJ now? All right, so I've got a free body diagram here. We know this is a zero force member. We already determined that. And this is that second cut we took. At this point, I could really just sum forces in the y direction. I've got 1015 negative times 4 plus 4/5 of CJ and so bringing this over, 4060 equals 4/5 of CJ. Multiply both sides by 5/4, CJ would be 5075. And that would be in tension. So now we were able, you can see we were able to solve for the three members we needed. CJ is 5075 pounds. CD is 253.75 pounds, which they would want us to write 254. Remember, 3 sig figs. So this would be 5080 pounds in tension. And we've got 2030 pounds in tension for HI. So those would be our three members in question and their three forces. Now we could have, as I said, summed the method of joints here, just summed forces in the y direction. We would have CH, which we calculated earlier, in the negative. We'd have 1015 negative, and we would have this CJ in the positive, which also came out 5080 when I did that earlier on the calculator. So that would be a good way to solve this particular problem. We can either do method of sections twice, or we could do method of sections once and method of joints to get this other member over here. We did need to recognize that this was a zero force member, but upon doing that, this became a rather easy problem. Hope that helped.